So in this problem, we have a relation R on the set of the Cartesian product of the set of natural number with itself. This simply means that R is going to be a subset of the Cartesian product of the set of natural number n with itself. And we have the definition for this relation. We have two ordered pairs a comma b and c comma d. Now a comma b is going to be related to c comma d if and only if we have a plus d equals to b plus c, meaning we take the sum of the outer elements of the two ordered pair, that is the sum of a and d, and this is going to be equals to the sum of the inner elements of the ordered pair, that means b and c. So a plus d equals to b plus c, and this is going to be true for all ordered pairs a comma b and c comma d picked up from the set, the Cartesian product of n with itself, and it is given that this relation is an equivalence relation. Now, using this, we need to find out the equivalence classes, the ordered pair 2, 3, and the equivalence class ordered pair 7, 3. Let us begin. So here, let's try to understand the given relation. So it is given that our relation R, this is going to be a set of ordered pairs. So let's consider contains the ordered pairs a comma b as well as the ordered pairs c comma d, and both of these two ordered pairs are going to belong to the Cartesian product of the set of natural number with itself, such that the ordered pair a comma b and the ordered pair c comma d are related by the equation a plus d equals to b plus c. Right, so this is our definition of the relation R. Now, in order to find out the equivalence class, so we'll start by first finding out the equivalence class for the ordered pair 2, 3. So we use the definition. So this is going to be a set. An equivalence class is a set, and this is going to be a set that contains the ordered pair x, y. So we are considering the ordered pair x, y such that it belongs to the Cartesian product of the set n with itself, such that we have x, y. So we are picking up a very specific ordered pair from this Cartesian product, and this ordered pair has been picked up in such a way that means it has to be related to the ordered pair 2, 3. So this is going to be the definition of the equivalence class. In other words, what we have here is the ordered pair x, y belonging to the Cartesian product of the set n with itself, such that so the ordered pair x, y related to ordered pair 2, 3 simply means that we take the sum of the outer elements, so that's going to be x added to 3, that's going to be equals to the sum of the inner elements, that's y plus 2. Okay, now furthermore we can rewrite the set as we have the set of ordered pairs x, y belonging to the Cartesian product of the set of natural numbers with itself, such that now what we can do, we can rearrange the terms of this equation x plus 3 equals to y plus 2. That's going to give us y will be equals to x plus 1. Fine. So here we have an equation y equals to x 1. This is how x and y are related. So we have to now find out the set of ordered pairs which contains x, y such that x and y are related by this particular equation. That meaning, since x and y both belong to the set of natural numbers, so if we choose x to be equals to 1, then the corresponding y value, that's going to be equals to 2. Then if we choose x to be equals to 2, then the corresponding y value is going to be 3. So if we use the x value to be equals to 3, then the corresponding y value will be 4, and so on. So this is going to be the equivalence classes of the ordered pair 2, 3. Next, we will try to find out the equivalence class of the ordered pair 7, 3. So we have the equivalent class of the ordered pair 7, 3. So here we're going to use the definition. This is going to be the set of ordered pairs x, y belonging to the Cartesian product of the set of natural number with itself, such that if we such that x, y is going to be related to 7, 3. Now, so we're going to skip this step. Can straight away write that x plus 3, that's going to be equals to y added to 7. Fine. So this is going to give us the equation, the ordered pair x, y belonging to the set of natural number n with itself, such that x plus 3 equals to y plus 7. So this is simply going to be equation given by x equals to y plus 4, or let's write it in terms of y. So we have y equals to x minus 4. Okay, so we have a new equation, y equals to x minus 4. Now we can easily define the ordered pairs. So if we consider y x to be equals to 1, So if we consider x to be equals to 1, then what is the corresponding y value? So that's going to be equals to negative 3. But y cannot be equals to negative 3 because y has to be a natural number. So we cannot take x equals to 1. We cannot take x equals to 2. We cannot take x equals to 3. And we also cannot take x equals to 4. So we have to skip these 3 or 4 values, 1, 2, 3, and 4. So we have to start with x equals to 5. So when we choose x equals to 5, then y value is going to be 1. So when we choose x to be equals to 6, corresponding y value, that's 2. When we choose x value to be 7, then the corresponding y value is 3, and we have the rest of the ordered pair. So here we have successfully obtained the equivalence classes of the ordered pair 7, 3. In other words, what you have said, so these ordered pairs 5, 1, 6, 2, 7, 3, and so on are chosen in such a way, and these are picked up from the Cartesian product of the set of natural number with itself, such that they are related to the ordered pair 7, 3. That means they follow the equation y equals to x minus 4.